Hello everyone, this is Professor Chan from Math 1245 speaking. We are going to be going over section 2.6 today. 2.6 deals with what's called composite functions, so it's just essentially what are we going to do when we have two functions. Okay. Now before we get to composites, let's just talk about some of the basics. So you will run in a situation where you have two functions and you'll be asked to add, subtract, multiply, divide, okay? So this should be pretty straightforward. If you do have problems following along, just make sure that you know some of the basics such as foiling, factoring, and all of the other things to keep in mind. So for example, right, number one, let's say they ask you to find f plus g, right? So all we would do is we'll just add these two functions. So I'm going to do 2x plus 3 plus x minus 1. And I'll add them together. And that'll be 3x plus 2. And then that would just be my final answer. Okay. If I'm being asked f times g, right, I'll do the same thing. Just notice this time, right, I'm multiplying them. I'm going to distribute. So 2x times x is 2x squared. 2x times negative 1 is negative 2x. 3 times x is 3x. 3 times negative 1 is negative 3. So this is 2x squared plus x minus 3 for the following right here. Okay, so as you can see, just a lot of basic things, right? I just kind of assume that you know. If you don't, make sure you practice that. Okay, factoring, combining terms, and foiling and multiplication distribution is pretty important. Okay, let me show you kind of one last one. Like example number 4, I have f of x and g of x, and let's say you're being asked to do f divide. Yeah, so if you see a slash, right, that means divide. And I'll do the same thing. Okay, and again, make sure you remember your basics. So remember, I have a fraction over another fraction. So all I'm going to do is I'm going to do 9x over x minus 4 divided by 7 all over x plus 8. Okay, remember, yeah, if I have fraction over fraction, I divide. And then, as usual, right, flip my reciprocal, or sorry, flip my second fraction, which means I multiply by my reciprocal, and I'll distribute. Okay, and technically you can leave your answer like this. You don't really need to actually distribute this, I believe. So this should be fine, and we'll just leave it like that right there. Okay, so let's talk about some of the basics for composites. So what is exactly a composite? Okay, so a way that we want to think about this is composites is what's called F composed with G, okay, in this formula. Now, let's talk about this right here. There's two different ways of writing composites. The first one that I'm going to draw an arrow, right, is you see this little white circle, right, that's not filled in and it's in the center. That's one way of saying composite. Or you can do a set of parentheses like this, okay? I do want to inform you guys this so that you don't get confused. They both mean the same thing. So a lot of times they'll read it as f of g or f composed with g. Okay, so that's the two ways that you'll be heard said. So you can say f of g or f composed with g. Probably the more common one is f of g. Okay, but yeah, if you see a middle circle between F and G, that's composite, or you can see a set of parentheses. So it's parentheses after the F and the parentheses G, and you have an X inside. Okay. So what does this mean? Okay. So let me go to this problem right here. So it says suppose that with f of x we have 2x squared minus x plus 4 and 4x plus 1, and we do f of g of 5, okay? So let's talk about what this means here. So when x is 5, I'm going to plug this into my g, okay? And the way that it's structured is your 5 is closest to whichever one's closest to the number, right? That's going to one you plug into first, and then it's going to go to f, okay? I'm going to kind of draw you kind of a flow chart of what's happening. So idea is I'm plugging 5 into g of x, okay? Whatever I get from g of x, that's going to get plugged into f of x, okay? It's almost like, I don't know, think of it as like two machines. You plug 5 into this machine, and this machine gives you this result. And then you plug in that result, and you plug into another machine, which we call f of x, okay? So we have these two functions like the following, where I have f of x and g of x. So if I do f of g of 5, right, and I'm writing it in a different way. Remember, either one of these is fine with a middle circle or with parentheses is acceptable. So idea is I plug 5 into g of x. So I say, well, g of 5 is equal to 4 times 5 plus 1, and then just some basic math. That will become 21, okay? So this 21 that I have, right, now goes to f of x. So I'm going to do f of 21. And remember, every single time I see an x, I plug in 21. So it's 2 times 21 squared minus 21 plus 4. So I have 2 times 441 minus 21 plus 4. 2 times 441 is 882 minus 21 plus 4. Okay, I'm throwing this in my calculator, and I should get 865. And that's my final answer right here. Okay, for the following. Okay. Okay, let me show you one more example. Let's see if I can make this so you guys can read this better. Sorry about that. Okay, so let me zoom out a little bit. Okay, so right here, if you have g of f of 3, right, this is reverse. Okay, I'm still using the same two functions that you see that I'm pointing to, right? F of x is 2x squared minus x plus 4, and g of x equals 4x plus 1. So I'm going to do g of f of 3. And this is going to be the following. I'm going to plug in 3 into f first. So if you notice, if you see this here, right, the 3 is closer to f. So I'm plugging 3 into f as opposed to g this time. So I'm going to do f of 3. I do 2, 3 squared minus 3 plus 4. And that will be 19. Okay. I'm then going to take my 19 and I'm going to plug it into g. So g of 19 is equal to 4x plus 1. 4 times 19 plus 1. Okay, so I have 76 plus 1, and that's 77 here. Okay. Okay. So hopefully you guys have gotten that. And then one last thing too. I'm going to erase this right here to work from above. But this should not be this shouldn't be that difficult to comprehend, but if I have something like this here, where I have g of 4, okay, and it's possible you can have a composite where you're going to the same function twice, right? Let me just rewrite this, but g of x we said is 4x plus 1. So I'm going to plug in 4 into g of x, and then the result will also come into g of x. So g of 4 is going to be equal to 4 times 4 plus 1. And that will become 17. And then I'm going to plug this 17 back into g of x again. So I'm plugging in the same machine twice, essentially. So I do g of 17 is equal to 4 times 17 plus 1. So this is 68 plus 1. That will be 69, and then that's it right here. Okay, so hopefully this shouldn't be that difficult. Okay, so yeah, just think of it as you're replacing it, you're plugging it into something twice, whether it be like g then f, then g, or you can plug in the same function twice. Okay, and then but if you notice, like other than the concept, the math is relatively straightforward. All you're doing is you're just doing kind of your basic mathematics afterwards. Okay, now once again in college algebra, specific topics, right, can be in terms of an algebraic math form, and it can also be a visual form. So composites are also fall in that same category where you have two different mediums, right? So we just did a math kind of version, and then you can actually do a visual version. So what you see down here is, if you notice, that you have a function in its visual form. So I have a graph of g of x, right? And then I have a graph of f of x. I'm going to make one of them a different color. Yeah, so I'll make g of x red, just so that we can kind of explain, right? So my g of x is the red graph, and then my f of x is my blue graph. Okay? So if I have f of g of 2, so yeah, I'm just doing this one right here, right? Let's remember what it's saying. We're saying we plug 2 in g of x, and then my output of g of x then goes to f of x. Okay, so let's talk about this right here. So I take my 2 and I plug in g of x, right? That's when x is equal to 2. So I'm saying, what is my y value when I plug 2 in for g? My y value, right, if I look at the picture, is the following. It is going to be, sorry, let me use a slightly different color. It's going to be 2, right? So I notice when I plug in 2 for g of x, y is equal to 2. And then I plug this into f of x. I'm like, okay, when x is 2 for f of x, what will that be? And I'm like, oh wait, that's negative 2. So that will be my answer here. Okay, so remember, your outputs is your y, right? Your input's your x, your output's your y. Remember that from the very first lesson we just did, okay, in class, right? Input's your x, output's your y, right? So I input into my g of x, I got a y of 2. That 2 now becomes my new input for f of x. I plug that in, I get negative 2. Okay. Now let's look at like one more example. I'm going to do a slightly different color so that you don't get confused. Okay, let's do purple. Okay, so let's say if I have f of g of 4, I'm going to plug 4 into g. and I get this one. So if I plug in 4, I have g of x, and that gives me 5. And then I'll plug in, oh, whoops, my apologies, I misread that. Sorry, I plug in 4. This one right here, whoops, sorry, this one right here is my g of x. So I get 2, and then I plug this to f of x, and I also get the same result here. Okay. All right, so I look right at x for 2, and that's negative 2 right here. Okay. And then let's just do one more. Yes. So let's look at g of f of 5. So I plug 5 in for f of x. And get y is equal to 1. And then I plug this into g of x. Remember, this time it's flipped, right, because it's closer to f. And I get 4. That's my final answer. Okay. So I'm going to end this right here because I'm going to do a separate video about specific functions with, specific for composites for an actual function. Okay. So we just kind of ran into basics. But yeah, that'll be it. Or I'll probably show you 2 more videos. But yeah, we're going to end here. If you have questions, let me know. Other than that, we'll come back.